everyone, so let us continue for example 14 on your lectures note page 62. Okay, so for the part C is we would like to use Newton backward difference to construct the P3x. And again, this is your divided difference table that we have done this last week, so just show you guys one more time, just in case for those students you want to double check it, so please do so. Okay, so first of all, let me write down what you need. Okay, so part C is using Newton backward difference. Okay, so formula. This is very important. You should know what is the formula. So we have P and X, the formula in general, that is equal to Pn xn plus sh. Okay, and this is equal to fxn plus the summation of k equal to 1 to n, and then times -1 power of k times -sk, and then this is the formula where we know that our -sk is equal to -s times -s minus 1, and then dot 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 multiply until -s minus k plus 1. Okay, and then over k factorial. Alright, so this is the formula for the backward difference. Now, you know that you are given 4 data points. That means 1, 2, 3, 4. But we know that the data points, we calculate the index of I begin from 0. So you have 0, 1, 2, 3. And then we know that the n is equal to 3. Okay? So for this case, we know that our n is equal to 3. So then you know that your n here is equal to 3 and your n here is equal to 3. So therefore, you know that, okay, maybe I put this. So we have P3x, which is equal to P3, and then this is x3 plus sh, which is equivalent to fx3 plus the summation from k equal to 1 to 3 for -1 power of k, -sk, and then x3 here. Alright, so what is your x3? So from here we know that this is your x3, so you know that this is your x3. Alright, so what about your h? The h will be the step size of this one minus this one, give you 1, and then 1 minus 0 give you 1, and then 2 minus 1 equal to 1. So then you know that your h is equal to 1. Alright, so then you can substitute into here. So that means, okay, I can rewrite this. This is equivalent to P3, x3 is equal to 2 plus s is still s, h is 1. So 1 times s give you s. Okay, so you can write where I know that my n is equal to 3 and h is equal to 1. Alright, so you can write like this. So this is equal to your fx3. So this is your fx3. So always know that this is your fx3. Alright, so fx3 is equal to -6. So you have -6 plus square root of, the sum of this. So you have negative 1k, and then this is your negative sk, and then k, and then this is your x3. So your x3 is, or you can just leave it as x3, okay? No harm. All right, so then you begin to take the summation. So we have negative 6 plus, okay, when k equal to 1, so this is 1. So I'm gonna write it down. So you have negative 1 power of 1, and then negative s1, your k is 1 now, and then 1, okay, and then fx3. So you can actually do not need to write the 1, all right? So you can just delete the 1 as well. And then when k equal to 2, so you have plus negative 1 square, negative s2, and then this is 2fx3, okay? And then when k equal to 3, so then you plus, when k equal to 3, you have negative 1 cube, and then negative s3, and then this is cube, and then fx3. Right, so I just write it down using a pencil here, so you know that this is when k equal to 1, you know that this is when k equal to 2, and you know that this is when k equal to 3, right? So I hope that you can see clearer. Okay, so then now you can open up these. So you have negative 6, negative 1 power of 1 give you negative. So you have plus negative 1 times, okay, negative s1. So you substitute your k equal to 1 into here. So now you have negative s minus 1 plus 1. So you see I write on a piece of paper. So for this one, okay, when we have negative s1, so that means we have, okay, so I write here. So we have negative s minus k is k plus 1. This is equal to negative s minus 1 plus 1. So then this gives us negative s, okay? This gives us negative s. So that means here is until negative s. So do you have this term? No, because the last term is negative s. So that means you have only negative s here. And then over k is 1 factorial. So 1 factorial is equal to 1, so you have negative s. So this is how you get it. All right, so now you have negative s, so you substitute into here. So you have negative s. Okay, what about these? Okay, always remember this one, fx3 is actually equal to this one only. Okay, so it is the same thing. So then you refer back to the table. Okay, so you are looking for this. All right, always remember, if you have forward, you're gonna use the information from the top here. Okay, this is forward. Backward, you're gonna use the information from here to here. Okay, so backward is from the bottom. Okay, from the bottom until here. If the forward, you from the top. All right, so now you see negative 6, you already use it. So negative 6 is here. Okay, and then this one is from here. Okay, so then you have negative 11, so you times negative 11, and then this one, negative 1 square, give you 1, so it's okay. Negative s2, and again you repeat the same thing, negative s2. Okay, so when your k is equal to 2, so now we have negative s2. So then you have here, you check out for the last term first. So the last term is negative s minus 2 plus 1. So minus 2 plus 1 is giving you negative 1. So that means you have minus s minus 1. So that means it's until here. All right, so that means you have negative s times negative s minus 1 over 2 factorial. So 2 factorial is equal to 2, so that means you have negative s times negative s minus 1 over 2. So this is the one that you have, and then you substitute into here. All right, into here. So then you plus negative s times negative s minus 1 over 2. What about the value of these? So the value of these will be this one. Okay, can you see from here? So you have times with negative 20. All right, and then you repeat for this term. So you have minus 1 cubed give you negative s3. So you do it by yourself, and I just give you what is the final answer for that. So it's negative s times negative s minus 1 and then negative s minus 2 over 3 factorial. 3 factorial is 6. All right, and then times with this one. Okay, so this is a cube, so you have negative 36. So times negative 36. Right? So you see, you have negative s, then followed by negative s minus 1, then followed by negative s minus 2 here. And then if you have another term, so you know that you have negative s minus 1, negative s minus 2, and then is negative s minus 3 over 4 factorial. All right? So this is the thing that you should know. Now, you simplify this. I will leave it for you. Okay? You do it by yourself here, and the final here you will get is negative 6s cubed minus 28s squared minus 33s minus 6. Alright, so this is the one that you will have obtained. Alright, so next, because they ask you to find px3, okay, you need to find p3x, okay? So how to find it? Okay, so now, okay, so this is the final. This is your P3 2 plus S. Okay, so what do you have to do? Okay, what do you know? So since your H is equal to 1 and your X3 is equal to 2, then what do we know? So then our X, which is equal to X3 plus SH, okay, how we get that? So remember, this is from here. Okay, X, your X and these, they are equal. So that means your X is equal to X3 plus SH. Alright, so this is what you have from here. So now you substitute your x3, so this is equal to 2, and then your h is 1, so you have s times 1. So that means you have 2x is equal to 2 plus s. So what is your s here? So this is the one that you need to find. You want to find s in terms of x. Okay, so you move this to the other side. So that means you have your s is equal to x minus 2. Then you substitute your s here with x minus 2. So substitute here x minus 2 cubed, x minus 2 square, and then minus, this is your x minus 2. Alright, so now you have your p3 x, which is equal to p3 2 plus s, which is, I just copy down the final equation on the previous page. This one minus 28s squared minus 33s minus 6. So now this is also equal to minus 6. You substitute your s with this. Okay, so you have x minus 2 cubed minus 28 times x minus 2 squared, and then minus 33 times x minus 2, and then minus 6. Okay, and then you simplify. I would like you to do it by yourself, so you should get your final answer is like this. Okay, if you get a different one, please double check and do let me know if I make any mistake. Okay, so this is your final answer for part C. So what you can notice, so if you see your part B answer, so your part B, let me find which part is your part B. Okay, from the previous one, your part B is this equation. Okay, 6x cubed plus negative 6x cubed plus 8x squared plus 7x minus 4. So you see, you get exactly the same. Alright, so you know that this is same as in part B. Okay, and part B similar to part A. So that means part A, part B, part C, they have the same answer. Right? Okay, then you are done for the part C. So now let us move on to the part D. So part D is you need to find the P3x by using Newton centered difference. Okay, so you need to find px3 by using Newton centered difference. Okay, so and again you should know what is a formula. All right, so you need to use the Stirling formula. So you need to use the Stirling's formula. All right. Okay, so the Stirling formula is pretty long, but I will just write it down here. So you have your Pnx equal to P2m plus 1x equal to your fx0 plus sh over 2 times your fx minus 1 x0 plus fx0 x1 and then plus with s square h square f x negative 1 x0 x1 and then plus s times s square minus 1 h cubed over 2 and then times with fx negative 2 x negative 1 x0 x1 plus fx negative 1 x0 x1 x2. Okay, and then plus dot 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 and then plus s square minus 1 s square minus 4 dot 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 until you times with s square minus m minus 1 square and then h2m f x negative m dot 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 until xm. You can always refer to your notes if it is not that clear. Okay, and then plus the last one is s times, okay, s times s square minus 1 dot 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 s square minus m square h to power of 2m plus 1 over 2 and then times with your fx negative m dot 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 negative m minus 1, okay, this negative m minus 1 dot 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 until x m and then plus f x negative m dot 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 x m plus 1. Okay, now this one is if your n is equal to 2m plus 1 is odd. Okay, if it is even number, you only do until here. Okay, you delete the last row. Okay, the last row you delete it, so that means it's until here for n equal to 2m equal to even number.